All right, so why don't we go over this together? And I just started the recording so that way it's not like super boring for the first 10 minutes or so. So if you're watching us after the fact, welcome. Okay, so I'll just start this from scratch. And in order, I don't know, I think just for now, I'll share my own screen, and then maybe in the future we can have somebody in the classroom put their screen up and talk through it. But let me show you how I'd solve this from scratch. So here's my PyCharm, and I've got Battleship open, which is kind of going to be the default for most of the time. And all I'm going to do here is right-click in any of this free space and say New File, and I can just call it scratch.py, right? And then I don't want to add it to the version control, so I'll just cancel that. And so if I want to be able to run this, I need to change my configuration, edit configurations, and just create a new one. Well, actually, I've already got something called Scratch, but you could use the plus sign, create it. You just want to make sure that you select the scratch.py as the thing to execute here. So click OK. And then I can just make sure that I'm going to be able to execute this file, say print scratch. And if I run this, I should see the message scratch. Okay? So now I can use this to kind of play around and write some Python code. So in order to create a class, we need to use the keyword class. And it's going to be of type car. That's going to be the name of our class. We're always going to be using capital letters for our class titles. Several of you asked about the proliferation of, on the exam, animals, and capital animal, lowercase. So there's a kind of a naming convention to keep all this straight. The name of the file that holds the class definition will be a lowercase of the class name. So you would expect, for example, here in our Battleship game, computer.py should define the class uppercase C computer. The import statements import other files, and so they're going to be importing a lowercase name. And so if we look at main.py in here, we'll see that we are importing the lowercase players, and that's going to be coming from this folder here. So then I can say players, and then I can say .human somewhere else and create a new human player. Okay, so when I create a object that becomes a variable, and I'll then use a lowercase name. So let's just keep going with our Scratch example, but I'll try to point out pieces as we go. So we're going to define this car, uppercase C. So I'm breaking the convention here. This is in a file called scratch.py, but this would typically be in a file called car. Okay, so I want a refuel and a drive function. So I'll just define those. Refuel. Now, Python's automatically going to add that self variable to the function definition because it knows that I'm inside of class. But if you were using a regular text editor, you'd actually have to write self, right? And then, do I want a parameter to the refuel function? Brooklyn says yes, right? And so that should be a number of gallons, right? And in order to add fuel to the car, I must have some kind of variable inside the self that is tracking fuel in the tank. All right, so self dot fuel level plus equals gallons. That would be how I'd add gas to the tank. Okay? But you see I've got the highlight over fuel level. It's an unresolved attribute. So let's see, Jack, how do I fix up this class so that fuel level is actually defined and given a sensible default value before somebody calls refuel?
The fuel level, keep hearing through the... So could you hear me through the
yeah.
thing, or
I can hear you.
can you hear me now?
Yeah.
Okay. I'm sorry, what was the question again?
So here I'm adding gallons to fuel level, but PyCharm is correctly warning me that this is not going to work because fuel level is undefined. So how do I give fuel level an initial value, for example, 0? when this car is first built?
You could do it in like a initialize function.
Yeah, we want a constructor. So we're going to have to define another method, def underscore init, and this is going to initialize our car. So here we would say self.fuel level equals 0. Okay? So let's stop defining the car for now and start using a car. How do we create a group of, I don't know, 2 cars? Like our farm example. I want 2 different cars here. This is my class, this is my recipe. How do you make a car? Now I want to create 2 cars. So Kyle, what do you think?
You just say like car 1 equals and then car of parentheses.
Yeah, and that parentheses is invoking a function here. It's invoking the constructor. The constructor returns back a car object. Okay, so then car 1, car 2 would be car. We could also have something called my cars, and that could be a list, and we say for I in range 2, my cars dot append a new car. And then you would have my cars 0 and my cars 1. Now when I say dot here, notice that the syntax, here, I'll just go ahead and remove my face from this one too. Oh, no. Sorry. Okay. So now we have my cars dot, and you see the autocomplete knows the type of this object, and so it suggests car things first. The F is a right, so we want to generally use the M here, the refuel methods. Okay, so dot refuel, and I'm going to give it, I don't know, 100 gallons of fuel. That's awesome, right? And say print. And then my cars 1 dot refuel, and then just 20 gallons in another car. So then I could print all of the fuel levels by saying for I in range 2 print And so notice how the way we use these objects, we never use the capital C car except to construct it. Okay? The only time I'll use the capital C car is to build the thing at the beginning. The rest of the time, I'm using the object itself, or in the case of an array, I'll index into that array and then use the dot operator. To call methods on that particular object. Okay? Now, the rule here, kind of Python won't throw an error if you don't do this, but here, the best way to use objects is to never directly change their state. Don't go in there and set fuel level equal to 100. Like in the exam, don't go in there and say animal vaccinated equals true. Right? If you're going to change the state of the object, it should be done through one of the methods. Only the method should actually change the state. And if you're very formal about using objects, you'd also say, well, actually, none of the state variables should be directly accessible. You should only be able to use a method to get something from the state. So you could also, if you're a purist, you could insist that fuel level shouldn't be queried directly like I'm doing it here, right? That's one of the member method attributes. You could say def get fuel level, and then the return self.fuel level, right? And this would be the purest way of using objects, that the self is totally hidden and encapsulated by the object, and you can only access and manipulate things through the methods. But that's kind of a lot of writing, and it doesn't add, I don't know, much capability. So very rarely in Python do you see people writing these, they're called getters, right? If there is a part of the object which you don't want people to see and interact with, what you should do to let somebody reading your code know is prefix the variable with an underscore. And that indicates that, hey, this is private in the sense that you shouldn't be accessing it directly. So you'll see in the code, in the Battleship code, a few of the member attributes of the classes there begin with an underscore. And that's to indicate that nobody should be directly poking or viewing that value. But let's just go on. And so this is directly analogous to the vaccinate function on the animal farm, right?
Sir, I got a quick question.
Yeah, go ahead.
So the self, like saying self dot something, only takes place in the functions, right? There's
Yes.
no way.
Yep, right.
Okay.
Yeah. And what actually happens when you call this, and one of you actually did this, I think, not on your example, when you emailed me some kind of like corrections to your exam, this actually works, which is, it shows you what Python's doing under the hood. You could actually say car, capital CAR, the class, dot refuel, and then you actually have to pass in two parameters here. The car and the gallons, right? So you would pay my cars, don't ever do this. This will work, but it's not how we're supposed to use objects, right? What's actually happening is when you write my cars dot refuel, internally, Python's restructuring that code to kind of do this number here, right? So self actually is the car thing, and it gets passed in. So maybe this is confusing you, but it just, since somebody did this and found out that it actually worked, this is not how you're supposed to use objects. Don't ever call the method on the class. Create the object, and then use the dot operator to access its methods. And self is only exposed inside of class methods. Okay. So let's finish this up with def drive, and now rather than gallons, we get miles here, and self dot mileage plus equals miles, but also self dot fuel level minus equals, and then we want to get if we have an NPG estimate, then we actually want to say gallons per mile, so it's a bit the opposite. Miles divided by self.mpg. But now we have two more highlights here. I don't have mileage defined or miles per gallon defined. So where do I put those, Maria?
You would just initialize them.
Initialize them where?
Within
like I can't set it equal to here, right? Mileage equals 0,
No.
because then every time I call this, I'm resetting the mileage.
right.
So where do you think in the three locations I've got, where would you
At
suggest?
the top under fuel level.
Yeah, so this init thing here is a special function. This gets called at the beginning when your object is first created, right here. And so that's your time to do all of your housekeeping, to get everything set up. So perfect, self.mileage equals 0. We won't put any miles on the odometer. What about self.mpg? Can I set that to a default value here? I'm kind of confused, right? I don't know what that should be. It could depend on your car, right? So the person building the car knows. These analogies are really, like, the reason we use objects is because they directly model kind of reality. So we can use a lot of analogies here. Like, hey, on line 17, I'm building cars. And when I build a car, it has a certain number of miles per gallon. So I somehow need to tell the car constructor the number of miles per gallon. Do you see that? So Paul, how would I restructure my init method, the constructor here, so that whoever builds the car can specify the miles per gallon.
So, for Nick, have the, self, and then miles per gallon. So whenever you have to construct, you have to enter in, enter that will after that, you'll be fine for it.
Great. And so it's not enough to just have this here, MPG, and in fact, PyCharm will highlight it and say, hey, this is unused. We actually need to, at line 5 here, put that into self so that later on, when someone drives the car, we have access to it. So we need to save the value. Right? Self is the persistence of our object. It allows us to store bits of information. So this is a bit tedious. It's very typical, though, in Python code to see all these parameters into the constructor and then a bunch of self dot operations right inside of here as we initialize things to default values and specify things that can't be defaulted based on parameters. So MPG here. Okay. Now we've got an error here. MPG is unfilled. So when you create a car, we need to specify its miles per gallon. Okay. So let's restructure this just so that you're kind of ambidextrous in how we're dealing with objects, right? We can create a car directly like this and say it gets 10 miles to the gallon. Okay. So then we'd say my car dot MPG, and I should get the value 10, right? Print and now we can play this and see MPG is 10. So now when I drive the car, right, I say, print fuel is at %d gallons, and then I can pass in my car dot fuel level. Sorry, I messed it up. Oh no. So now we should see that the fuel started at 0, but I got up to 100. And you can play with the objects too directly in here. So if I set a breakpoint and use the bug icon, okay, and then go to the console, I have my car, and you see that it's a car object. I can say my car dot fuel level and check what it is. It's 100. I can refuel it, and so you can play with your objects in the terminal here. And now it's at 110, right? I don't know, the display on this large font size isn't great for the terminal, but use the console to play with your objects and try to get used to the fact that these objects have capabilities, and we access those capabilities by using the dot operator. Okay, so that's really fundamental to the rest of the course in the terms of everything we're going to be using as objects. Okay, so like on the exam, the last 2 questions are just a couple lines of code. It says for animal and animals, you get an actual animal then, and you say animal.draw, right? And it draws itself. It takes care of that for you, right? Several of you tried to put a rectangle together yourself. Let the animal draw himself, right? We're going to delegate responsibility to the objects. What do we think? The objects make more sense now? Is this helpful?
Sir, how do we, can you just go over how we then, use objects in other files?
Okay, yeah, sure. So let's say that I've got this car. I've created this car here, and now I want to make a simulator that's going to use my car, right? So I'll create a new file here. I'll say right-click here, new file, and I'll call it sim.py for simulating, I don't know, some driving. I'm not going to add it to version control. And if I want to then create cars here, we'll notice there's a problem, right? My car equals car, parentheses, and it's like saying that there's a red line here, it's not going to work. Because this file has no definition for car. I need to import the car definition into this file. So the way we're going to do that is using the keyword import and then the name of the file that we'd like to use. In that case, it's called scratch.py. Now, I'm already regretting this. I'm going to rename this to car.py just so it follows the typical structure here. All right, so I'm calling it car.py. So then I would say import car. Now that's not quite enough here. Car is still undefined. Because this is looking in the namespace of this file. There's nowhere in here where I've created a car. There is something inside of this file here. So I can say within that file, car, dot, and then there you see the C, right? There is a my car thing there. Or sorry, there's a car class there. And so that's why we have this proliferation of similar words. We're going to import the file. From that file, we're going to access something that's defined in the file, and namely the class. And so that's always going to be a capital C. So car.car is in the car file. Get the car class. And then I use the my prefix here because otherwise, if you said car equals that, this variable will conflict with that variable. And we'll get an error. So you could call it something totally different like Toyota, but if you don't have a better name for it, the typical thing to do is call it my car or my ship or my animal so that you don't stomp on the name that you imported here. Does that answer your question, Marco?
Yes, sir. Thank you.
Mm-hmm. Yeah, so we haven't gone over imports much in class. They get pretty tricky, it's as simple as you see there. You can make it more complex, and some of the tools in the Battleship code, if you'd like to look at how the imports are structured, you can use that as a start to kind of Google around it and look for other things. But I'm not going to worry too much about the import syntax. Okay. All right, so please start working on, or continue working on the lab that's going to be due on Thursday. If there's a problem, if things aren't looking good, please be proactive and let me know prior to Wednesday your issues. So that way in class we can talk about them. And then, if we need to extend the lab even further, we can. Okay, so, but if you wait until Wednesday evening and say, sir, it turns out the lab's really hard, then I'm like, yeah, it is. I don't want to grant extensions at that point, right? So please be proactive. If it looks like you're not going to be able to finish it, you should be able to realize that and earlier than 24 hours out, and just let me know, and I'd be happy to flex the schedule and make sure it works for everyone. Okay? All right, so the next topic we're going to discuss is actually communicating between two computers. And for that, you'll need some hardware, which I'll leave out with TSD and once I can figure out how that's going to play out. And I think it'll be good. Okay? Any questions?
Sure, could I just show you a piece of code that I'm having trouble with?
Yeah, definitely. Let me just make sure. Is there anything else from anybody? Okay, well, let me enable your screen share, Kyle, there, and then I'm happy to take a look. All right, well, I will see you, the rest of you, on Wednesday. Hopefully in class. Great. Okay.
Do you see this?
Uh-huh, yeah.
So I've gone up until where it'll pull you should be able to pull what you type and make it into the thing guess.
Yeah.
So I think no, this is a computer, this is the human. So it should be able to